Bismillahirrahmanirrahim. Today our topic is mass and weight. Generally, mass and weight are considered similar quantities, but it is not correct. They are two different quantities. Mass of a body is the quantity of matter possessed by the body. It is a scalar quantity and does not change with change of place. It is measured by comparison with standard masses using a beam balance. On the other hand, weight of the body is the force equal to the force with which earth attracts it. It varies depending upon the value of g acceleration due to gravity. Weight by a body of mass m is related by the equation W is equal to mg. W is equal to mg. Weight is a force and thus it is a vector quantity. Its SI unit is Newton, the same as force. Weight is measured by spring balance. Newton's third law of motion. Newton's third law of motion deals with the reaction of the body when the force acts on it. Let a body exert a force on another body B. The body B reacts against this force and exert a force on body A. The force exerted by body A on B is the action force, whereas the force exerted by body B on A is called the reaction force. Newton's third law of motion states that to every action there is always an equal but opposite reaction. According to this law, action is always accompanied by the reaction force and the two forces must always be equal and opposite. Note that action and reaction forces act on different bodies. Consider a book lying on a table as shown in figure 3.8. The weight of the book is acting on the table in the downward direction. This is the action. The reaction of the table acts on the book in the upward direction. Consider another example. Take an air-filled balloon as shown in figure 3.9. When the balloon is set free, the air inside it rushes and the balloon moves forward. In this example, the action is by the balloon that push the air out of it. When set free, the reaction of the air which escapes out from the balloon acts on the balloon. It is due to the reaction of escaping air that moves the balloon forward. A rocket such as shown in figure 3.10 moves on the same principle when its fuel burns. Hot gases escape out from its tail with very high speed. Reaction of these gases on the rocket causes it to move opposite to the gases rushing out of its tail. Tension and acceleration in string. Consider a block supported by the string. The upper end of the string is fixed on the stand as shown figure 3.11. Let W be the weight of block. The block pulls the string downwards by its weights. This causes a tension T in the string. The tension T in the string is acting upwards at the block as the block is at rest. Therefore, the weight of the block acting downward must be balanced by the upper tension T in the string. Thus, the tension T in the string must be equal and opposite to the weight W of the block. Vertical motion of two bodies attached to the ends of the string that passes over the frictionally pulley.